Okay, so this is Engentica. It's our new user interface and our new agentic orchestrator. So here we have OpenRex open already. It's already been imported from Altium format. Engentica, when you import, it builds a semantic database of your electronics design and applies deterministic, rule-based, and AI-assisted reasoning to verify things like compliance and detect implementation risks, and also surface engineering guidance grounded in your circuit. So it understands the actual design structure, things like components and interfaces and design rules, and also supporting documents around the actual design. And the idea is that instead of forcing engineers to manually cross-reference schematics and datasheets and app notes and design guides, Engentica lets you interact directly with the design itself. So let's start with a generic or a general engineering question, EMC guidelines for Ethernet interfaces. I'm just asking, what are the guidelines for addressing EMC on Ethernet interfaces? And you can see obviously here there's an Ethernet PHY. So in the response, which is coming back from language model, here I'm actually using Anthropic's Haiku 4.5, which is a fairly lightweight language model. It's certainly not frontier, but it's fast, and I like that it's fast. So what comes back is not just a generic language model answer. So Engentica is combining three things into one grounded response here. So it's using the imported design data and deterministic design rule results, and also relevant skill guides. And so what's happened is it's recognized that this design contains an Ethernet MDI interface. That's been surfaced there, and it's identified the PHY chip and the connector, the MagJack connector J6, and the PHY, which is this IC right here. And what it's doing is it's synthesizing practical guidance around high impact EMC decisions, things like shield connection strategy, Bob Smith termination, transient voltage, TVS diode placement, and cable selection, and things like that. And it's also suggesting things that are not recommended. So it's surfacing gotchas and things to watch out for. Single 1 nanofarad Y cap with a 1 mega ohm resistor, which is sometimes recommended. In the skill guide that I'll go into in a minute, that was actually highlighted in a case study as the worst configuration that you could choose, with some measurements of up to 5 dB worse for radiated emissions and failing burst immunity and things like that. And because it knows that we're using an integrated magnetics approach with the MagJack built-in transformer, it knows that certain risks are actually lower. So you can see the power of this. It's synthesizing your design data with skill guides. So you see at the bottom of this response here, there's references made throughout the response, and the citations are at the bottom here. So there's a lot for this skill guide. And the Ethernet EMC guidance here was distilled from Worth Electronics, great application notes. So actually this one, which is ANP 116 gigabit Ethernet from an EMC perspective, and also the RD016, their front-end reference design. So instead of storing these as passive PDFs that just live on a server somewhere and may be missed, Engentica turns these into structured, actionable knowledge that can be used interactively in the context of the actual design. And these skill guides are proactively surfaced based on objects in the design, and they're also surfaced automatically, as it was in this chat, in response to relevant questions. So you don't need to know what's available. You don't need to find these application notes on the internet. They're built in, and they're surfaced automatically in response to questions. So you can probably see that that's fairly powerful. Now let's look at something more specific. So I'm asking check MDIO interface versus U7 datasheet requirements. So the Ethernet PHY is U7 right here, and here is the MDIO interface. And this is where Engentica gets really interesting as well. Engentica identifies the MDIO interface, and it's finding relevant pages in the datasheet for U7. It extracts the requirements from the datasheet, and it checks the schematic connectivity against the requirements surfaced in the datasheet. So this is really, really powerful. And what it's found here is that the datasheet calls for some series termination and pull-up. And it's actually found that in the design. We've got pull-ups here and series termination right here. So it's found that our design is in accordance with what the datasheet calls for. And again, for citations, we spent a lot of time implementing this because we know how trust and references are so important for engineers. You can actually pull up the pages that were used to distill that information into the answer. So pinout table and information that the LLM used to collate this data and check it against our design data. And one last query here, check decoupling for U7. So U7 has a number of power supplies here, and we have a lot of decoupling. And so the agent should identify all 5 power supply rails, and it's mapping decoupling capacitors to each domain. And we also have deterministic design rule checks for decoupling. So it's synthesizing all of that data into one response. So here's a summary, and so it's found the deterministic design rule results, and it summarized the capacitors that are on each rail, and it's given an assessment, pass. This is a great design by Robert Ferenac, so I'm not surprised that it passed. But interestingly, it's also surfaced our decoupling skills guide, decoupling and power integrity, where we've encoded best practices for decoupling into a concise guide. So often what you'll find with language models is that the guidance is not in accordance with modern best practices. And the reason for that is that they're often trained on app notes that are either incorrect or out of date. So you'll often see responses from language models where they recommend the old school 1 nanofarad, 10 nanofarad, 100 nanofarad decoupling for each power ground pin pair. And we don't want to do that. We know that's wrong now because we want to avoid those anti-resonances that can come up. So we encode those sorts of modern best practices into skill guides, and those are surfaced to the language model, which informs it about the best approach that we want it to take. So we think these skill guides are going to be very important because they essentially synthesize any application note or guidance document or case study into actionable and proactive and in context information that you can spread across your team. So for enterprises, this can be extremely powerful because you can essentially standardize a particular style of design, and you can encode deterministic rule checks based on your in-house guidance. And so what we have now is we have a set of core skill guides, and then we also have a set from Worth Electronics. They're actually a content partner for Engentica, and they have a great set of app notes and case studies that we've encoded into skill guides. So those are surfaced automatically. but you can also filter by vendor. So we've also created a few skill guides based on some great Texas Instrument app notes, and I definitely see this expanding into the future to cover, many more areas covered by great app notes, because obviously they're very, very useful. And for enterprise customers, we can also build custom skill packs where we can encode in-house design guidelines and lessons learned and review checklists and case studies, so that every engineer on the team gets that knowledge surfaced in context and proactively while they're working. So it's going to be great for upskilling employees at scale and also enforcing design guidelines that you want to see across your organization. So this is Engentica. Just to summarize, the tool understands your circuit, it performs deterministic analysis, it reasons across datasheet information and contextual guidance in a single workflow, and engineers can ask broad conceptual questions, verify implementation details against source requirements, and access deeper design guidance, all without leaving the context of the design they're working on. And right now we're working as fast as we can to release this. We're not there yet. We've still got some work to do. But if you want to be kept in the loop and informed when we have updates available or when we release beta access, just sign up for the waitlist at Engentica.com. That's Engentica.com. Thanks.